Anna Jones. The title is Keeping the World Habitable, which is actually more optimistic than it might sound. So I'd like to first just set the scene and explain why we do what we do. Many of us started working on coral reefs because they're beautiful and because we like to dive in exotic places. But there are actually important reasons why we need to look after reefs. So this map of the world shows the extent of reefs throughout the tropics. So the three lines there are the northern and southern tropics and the equator in the middle. And the thing that leaps out of you immediately looking at that map of the world is that Australia is almost unique in the coral reef world, in that of all the countries that have reefs, really Australia is the only one that's a wealthy country. We have a stewardship of about 15% of the world's coral reefs, and almost all of the rest is in developing nations. And so that means we have a capacity, and in fact I would argue a responsibility to help our neighbours in the region in terms of looking after their reefs as well as looking after our own. They're very critical ecosystems that provide so-called ecosystem goods and services to a lot of people. An example of an ecosystem good is a fishery. An example of an ecosystem service is protection of the shoreline from erosion or the provision of a global tourism industry. Unfortunately, about a third of the world's coral reefs are already pretty much destroyed, and another 30% are threatened locally by things like runoff from land and by local overfishing. And the rest, the remaining 40% or so, are increasingly threatened by climate change, because even the most pristine and the most remote reefs can't hide from global warming. And as I said earlier, there's a huge need because of the reliance of so many people in developing countries on reefs for food security and for income. There's a real great need for improved capacity building and research and management of coral reefs. So let's talk about reef degradation and what we could potentially do about it. So this is a before and after cartoon, it's not a graph, of an idealised food web. So if we look at the before, this is before there were significant numbers of people. This is a typical cartoon of a food web. So at the top are top predators, things like sharks, crocodiles, and so on. In the middle are smaller predators. Further down are herbivores, and at the bottom are things like plants and corals and sponges. And the arrows basically say who eats whom. And an ecologist can go out and measure the width and length of those arrows if they want to understand how the food chain works. More typically, though, is the non-graph on the right, which shows a new top predator, namely people, depicted here by two men in a canoe, hopefully not on the proverbial river without paddles. And the strength of the red arrows there show the significant interactions between people and ecosystems. And more we recognise that people are part of the ecosystem, they're not separated from it. So there are two ways to look at that right-hand picture. One is to say, aren't people terrible? Look at the horrible distortion and simplification they've inflicted on an innocent, once pristine food web. That's sort of the half-glass empty approach. The other way to look at it is to recognise the incredible importance for functioning ecosystems on coastal societies and economies and the linkage between people and ecosystems. Now, most of our management strategies today globally are aimed at protecting the system as it currently is, maintaining the status quo, whereas some of the more enthusiastic conservation groups would like us to go back to the before scenario. But I would argue that staying still or going backwards is no longer possible because the world is on a conveyor belt to somewhere different. So the title of our symposium, which we ran over the last 2 days, was Coral Reef Futures. And futures is plural because we've got some choices to make. We're not going to stay where we are. We're not going to go backwards. We're going somewhere else because the planet is on a conveyor belt. Now, if we continue with business as usual, that somewhere else will be a horrible place. But we have some choices that we can make. We're certainly not doomed to further degradation. But clearly there are limits to the number and strength of those red arrows. There's only so much stress that we can put on these ecosystems before they finally collapse. And as we saw a moment ago, about 30% of reefs already have collapsed. So the next picture is not a graph, and it shows a concept called planetary boundaries. So if we think of the health of a reef, on the left being a healthy, intact reef that's got lots of corals and fish, as we increase the stresses to that reef through global warming, overfishing and pollution, eventually we'll reach a threshold or a tipping point and the reef will collapse. And I'll show you a picture of that in a moment. And we will end up in a bad place that we want to avoid. The question is, where is that threshold? We're not quite sure. So at the moment, the world is debating whether we should be trying to limit climate change to 2 degrees or 4 degrees, whether we should be looking at 450 parts per million of CO2 in the atmosphere, 500, 550, or whatever. I would argue that we have already left the safe operating zone when it comes to coral reefs. Already 30% are on the right, in the bad place we want to avoid, and most of the rest are approaching that threshold. We're already in the pink zone. So I think the target for CO2 in the atmosphere we should be looking at is a little bit less than we're already at now. It should be about 380, in my opinion. Okay, there's actually evidence that supports this concept. And so this is a before and after picture. This is the same reef, and I took that picture on the left in 1979, and I figured out today, to my horror, that was 30 years ago. I learned to dive at a very young age, so I was actually only 4 years old when I took this picture. It's a reef in the Caribbean, and these 2 species of corals, I won't bother you with their Latin name, were incredibly abundant 30 years ago, and they are now both listed on the US EPA endangered species list. They've just become incredibly rare. So the picture on the right is the same reef, and what happens when these sorts of crashes occur is that the reef reaches a tipping point as stressors reach a critical level, and then the reef collapses into this alternative configuration. And that alternative on the right, the degraded system, is actually very stable. It locks into that system. So if you think of baby corals trying to recruit through that thick mass of seaweed on the right, they just can't burrow through that seaweed, and if they could, they'd be smothered. There isn't enough light for them to grow. It's also a bad place for a baby fish to recruit to. There isn't enough three-dimensional structure, the point that Morgan made. So that system's actually quite stable, and once that degradation occurs, it's almost impossible to reverse. The moral of the story is prevention is better than cure. So I'm going to finish up with some take-home messages. One is that the world is on a conveyor belt driven by human population growth, rising consumption, and climate change. Yet most governments and management agencies are still focused on maintaining the status quo. Most of the incentives we have are to stay the same rather than seeing incentives for change. And many conservation groups would like us to go backwards in time to a pristine past. It's just not going to happen. So in a rapidly changing world, standing still or going backwards aren't an option. The trick is to actively steer forward, not to be passive passengers on the conveyor belt, to a place that recognises the importance of healthy ecosystems for human well-being. Thank you very much.
Now, just before we get to the questions, I'd just like